Hello everyone, welcome to this class. Now we are going to deal with graph of quadratic equation. Remember what we do when we solve for the example, try to use their own graph to solve, but when we are solving for the exercise, we start everything from scratch. So let's go through this example. Example 2, we have this. A quadratic function x is an expression in x in which 2 is the highest power of x. For example, 3x squared minus 5x plus 1 is a quadratic equation, is a quadratic function of x. So quadratic function is simply a function where in x, that's if you are talking about x, it can be any algebra can deal with any alphabet, but in this case, I'll deal with x. But the highest power must be 2. Once it's more than 2, it's no longer a quadratic equation. If it's less than 2, like the one we did in the previous class, which is 1, that one is a linear equation. So let's go to the first example. Draw the Cartesian graph of y equal to x squared plus 2x minus 3 for the value of x from minus 4 to plus 2. Use the graph to find. Before we come to this, let's first deal with this range. Are we together? Let's first deal with this range. Well, first, let me zoom this in first. So we have this. The equation is x squared plus y plus 2 squared plus minus 3. First, look at what they did. They first put out x, then x squared. Where they get this x squared? The first x here plus 2x squared, this minus 3, that. Then when you add everything, you get y. Instead of solving it the way we did in the previous class of linear equation, we have to start doing it one after the other. They just drew a table to make it easy. So let's work with the table. I don't think we are seeing it. Okay. For the first one, they say it started from minus 4 to what? 2. So let's go for minus 4. This is going to take our time. For minus 4, we have minus 4. Then when x squared is minus 4 squared, which is 16. Plus 2x is 2 times minus 4, which is minus 8. Minus 3 is just a constant, so everything will be minus 3, as you can see. Just a constant, this constant. Go to the next one. The next one is when x is minus 2. That's the range. Minus 2 plus 1, minus 1 plus 1, minus 1, minus 1 plus 1, 0, 1, 2. So for the next one, x is minus 1, x squared is 9. Minus 2 times x. Since x is already minus, we give you minus 6. That's 2 times minus 3 is minus 6. Then the constant. Then when you add everything here, you get 5. Let's do it. Mind you, are not adding the x, because what you are adding is what you see in the equation that you are given. So what we are seeing, we are starting from this x squared. So we're just adding from here to get our y. This is just the range of x that we're using to generate these ones. So 16 minus 8 is 8. Then 8 minus 3 is 5. For the second one we did, 9 minus 6 is 3. 3 minus 3 is 0. So let's go to the next one, minus 2. Minus 2 squared is 4. 2 times minus 2 is minus 4 plus a constant. So 4 minus 4 is 0. Minus 0 minus 3 is minus 3. Let's go to the next one. When x is minus 1, we have, when x is minus 1, minus 1 squared is 1. 2 times minus 1 is minus 2 plus a constant. So 1 minus 2 is minus 1. Minus 1 minus 3 is 4. The next one, when x is 0, x squared is still 0. 2 times x is still 0. Then minus 3, which is a constant. 0 plus 0 minus 3 is minus 3. The next one, when x is 1, 1 squared is 1. 2 times 1 is 2. Then minus 3. 1 plus 2, 3. 3 minus 3 is 0. Next one, when x is 2. 2 squared is 4. Right? 2 times 2 is still 4. Then minus 3. 4 plus 4, 8. 8 minus 3 is what? 5. So we've gotten all the values of y that we need for these values of x through this table. Let me shift this. We've gotten it. Then the next question is, draw the Cartesian graph. Okay, now this is the graph. Let's start. When x is minus 4, y is what? 5. So this is x being minus 4 here. First, let's find the, how will I put it? Okay, see, I'm just trying to make us see this and this so we can capture it. But what I'll do is I will zoom only this, say this with my mouth, and just hope we'll follow up. So let's zoom. So first we are going to do is to know the scale this was done in. Here we have that from here to here is 1, and we have 5 line before we get to the 1. So for the y-axis, it will be 1 over 5, which is what, 0.2. So we already know that 0.2 units, that like we know that this each of this line is 0.2 for y. But if you want to look at it, let me say this is 1 cm. 1 cm represents 1 unit of what? Y, depending on what the cm that this is. But at least we've gotten this line. That's the most important thing. For the x side, is the same thing, because it's still 1 over 5, so which is same as x. That has been done. First thing, listen, when x is minus 4, y is what? 5. When x is minus 4, y is 5. So let's trace. This is minus 4. So where will 5 be? This is, okay, that will be on the positive side, sorry. When x is minus 4, y is 5. So this is 5. This is minus 4. Mind you, they've already given out this letter. And you see the way that this thing moves towards this side, because the negative sign has more values. Y for the y is almost equal, because here is 5 and here is it gives 5 5. If you look at the table, let me show you the table again. This is the table. For y you have 5 and 5, but for x you have the minus side has more value than the positive side. So when you come back to the graph, it reflects that way. So let's start. When y is minus, okay, let me do something. I'm going to write this now because I know it's important to see it while we do it, so we can see it now. So when y is minus 4, x is 5. So minus 4 and 5, this is 5 where they meet. So marked. When y is minus 3, x is 0. So y is minus 3, x is 0. So here. When y is minus 2, x is minus 3. This is y being minus 2 here. X is what? What am I doing? Sorry, when x, forgive me, the first one is when x, y. So when x is minus 2, y is minus 3. So this is x being minus 2. Y is now going down to minus 3. Look at it, minus 3. So when x is minus 1, y is minus 4. X being minus 1, y being minus 4. When, see, we're no longer using these stuff that we put here, because we are getting it direct from our point. But you know, when you get something in between, this is what you're going to use to know the actual value it will be. So let's continue. So when y is minus 1, x is minus, okay, I think I've done that one. When y is 0, this is y being 0. When x is 0, forgive me for the interchange, I'm sorry. When x is 0, y is minus 3. This is 0 and y is minus 3 here. Mark. When x is 1, y is 0. So x 1, y is 0 here. When x is 2, y is 5. So these are my values: 1, 2, 3, 4, 5, 6, 7. Let's count it: 1, 2, 3, 4, 5, 6, 7. So after that, you're going to draw a line. This is a parabolic line that will link, unlike the previous class where we have to use meter rule to draw a straight line. But in this case, what you're going to use something like something that is bendable. Any bendable item. I'm coming. Let me look for one. Mind you, you're going to use a bendable item. The idea of using a bendable item is that's the way you can get the line. Remember this graph, we are still going to use it to solve for other questions that they ask here. So let's assume you use something like rope. No, rope can just connect it at any random way. So you have to look for something that is bendable, so that when it crosses the line, because it's a parabolic, when it crosses the line, and make sure that the thing touches all your points, something like this. You see, I just brought out my pen, but you know this one is smaller than the line we are using, so you have to look for something long enough to cover the line. So when you use it, something bendable, you hold it in and use your drawing item tool to draw this line. So this is just an example. We are not, when we want to do our own, we are going to see how we are going to go about it. So after that, you get this line here. This line you are going to get. From there now, we'll now start solving for our other questions. Let's go to those ones. So now we are going to, now that this line has been drawn, we are just following what they did. This is not what was. So we are going to now start our own. The second question is the value of x when y is 1.5. Mind you, when you are being asked this kind of question, you are being told to solve it from the graph. So the value of y when x is 1.5, I'm making that mistake again. The value of y when x is 1.5. So, and it's positive side of it. So this is 1. To get 1.5, that's where this is our stuff comes in. The first line is 1.2, second one is line 1.4, third one is 1.6. So 1.4 and 1.6, the middle, you trace it up. See, they've already done it. You trace it up, dot, 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 dot. Wherever it meets this line, this is your curve. You trace it and come. So coming here is hitting it at 2.2. But 2.2, but just somewhere around 2.2, above 2.2, so you can say 2.25, something like that. And that's what they got here. When y is 2.25, when x is what? 1.5. Mind you, if you draw this by yourself, there is such chances that you're going to have a slight difference. For you to confirm the real answer, just put your x as 1.5 and do these calculations here. Let me just solve for one so that we'll see how it is being solved. I will now use it to know what we are doing. When x is 1.5, we can just say y from the graph is x squared plus 2x minus 3. You can go through this process they are going through, but let's just solve it. 1.5 all squared plus 2 times 1.5 minus 3. So 1.5 all squared will give us something like 2.25 plus 3 minus 3. 3 minus 3 is 0, so you're left with 2.25. So this is just for you to confirm if you are close to the answer. Don't use it to solve. When you are being told to solve with your graph, let's assume you are solving a theory question. The examiner that is marking your script will expect to see this dot and be sure that this dot actually coincide with your answer. So you don't cheat by using this. This is only when you're not being told to use it. It's used for cross-checking or whenever you're solving with a graph. So the next thing you're going to solve for is the value of x when y is 1. So y is 1. This is 1. You do dot, 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 you reach here where it meets the graph. You now do dot, 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 dot. You meet it at 1.2. It shifts slightly, which is 1.25. But meanwhile, because you are dealing with a quadratic equation, remember what I told you. When we're dealing with linear equation, the answer usually gives us one answer. But then this is y being 1, and we're able to get 1.25 at this point. At the same time, if you draw a straight line at 1, it's still hitting y again at another point, which if you trace it down, it will be 3.2, and the shifted small, which is 3.25. So you're going to get two answers. That's one thing about quadratic equation. The values of x at y usually most times give two answers because it's a parabolic equation that has both the one side and the other side. So that's the two answers you are seeing here. This one is minus 3.25, while this one is plus 1.25 at y being 1. The next question will be asked the minimum value of this equation. The minimum value simply means the lowest value you can see in this graph. And when you are dealing with quadratic equation, the minimum value, you have something like minimum value or maximum value. You understand? You don't have that in linear equation. Linear equation can be infinite most times, but the minimum value or the maximum value. So that's like where the line curve. In this case, is minimum value. There are some line you draw, it will curve upward, that one of maximum value. So in this case, you are dealing with minimum value. So at what point does the line curve? That's -4. Very clear. Very, very clear. So if you come to our answer, is -4 is the minimum value. Very simple. The next one is the value of x when y is least. The value of x when y is least. They are trying to tell you the lowest value of y. The lowest value of y from our graph is still the same -4. So indirectly, they are trying to tell the value of x at minimum value. So that -4, you trace it up, it will give you -1 for x. And that's it here, -1 for x. So that's example 2. I hope we are getting it because we are going to solve another example before we now move to exercise where we are going to start it from the scratch and do everything by ourselves. So this is example 3. This example 3, the graph has been drawn for us already. They didn't even want us to start calculating for the range for solving. They've already calculated the range and already drawn the graph. Mind you, for this curve, as I said earlier, find something that is bendable that will connect all the points. That's the easiest way. Something like broom, bend like what I did, my pen pipe. There's some other items you can buy, like when you have your mathematical set, that's something like French curve and the other. But the one thing with French curve is that sometimes it will curve and maybe go like this or curve and So make sure that any curve you're using must connect all the whole dot first before you mark. If you're going to use, let me say you're using French curve that connect like this, you want to go and connect this one and then continue connect, you will miss it. That's why I don't even want to bring it up initially. So let's go. You've already drawn the curve, the range, and everything. It's just for us to now use the graph to solve for questions. So you've done the hard work for us. So the next thing is, what is the maximum value of this? As I told you, see in this case we are dealing with maximum value. Remember what I told you in the previous, when we did this graph here, that one is giving us minimum value. So the graph of a quadratic equation is that we either give you maximum or minimum value. When we deal with those stuff, especially when we are dealing now with our dy dx, you'll get to see how to know all those things. But in this case, let's stick to what you're doing. So the maximum value, what is maximum value of this? The maximum value is this point. At a point where, let's first know the range, let's first know the scale of this thing. We have here for the x-axis is 1/5, right? Because 1, 2, 3, 4, 5, and we're having one for every 5 line, we have 1 unit. So x-axis is 0.2. Then for the y-axis, for every, this is 10 lines from here, 1, 2, 3, 4. If you count it, is up to 10, and we're having 10 units of y. For the y-axis is 10/10, which is 1. So one line for the y-axis represents 1 unit of, but for the y-axis, one line represents 0.2 units. So let's have that in mind. So the maximum value, we are going to count 1, 2, 3, but it's a little bit slightly above the 3. You can call it 3, you're not far. But if to be more accurate, the answer for this is 3.1. But even if you call it 3, because the line is just a little bit above it, we are still close to the answer because it's still 0.1 difference in error. 0.1, 0.2, anything not more than 0.5 is not too bad. So that's for the first one. So what value of x is y greatest? So at the point where y is greatest, what is the value of x? So this is the greatest value of the curve. So you just trace it down. Make sure you're using the center of the curve. Where this curve, the center. You understand? The center. Don't go and mark it here. Here is not the maximum. Here is the maximum. The point, the climax point, that's usually the center point of it. So if you trace it down, you're going to get, here is 2, 0.2, 0.4, 0.6, almost close to 0.8, right? So I can call this 0.75. Very simple. The next one is, but looking at it that is close to 0. Even if you call it 0. Let me say call it 0.979 or 0.78, you are still close to the real answer. So the next one is, find the value of x when y is -7. Where is y -7? This is the minus side of y. Let's count it. Remember our scale. 1, 2, 3, 4, 5, 6, 7. This is at point where y is -7. So you just draw a straight line. See, it's meeting the line here and also meeting the line here. At this point, it's meeting the line exactly at -3. So -3, and at this other point, it's meeting the line at the center of 1 and 2, immediately the center. So that's plus 1.5. So these are the two values of x when y is -7. So the next question is, for what range of x is y positive? This thing is not, I don't know. Some of us will wonder, how do you know the real, I don't really know like a real formula for it, just for you to understand the question as and relate it to the graph. Like now they have been as the range of value of x where y is positive. Look at all the points where y is positive from here to here. Look at the graph. Is, you know this is 0. For up of this 0 for the y-axis is positive, y down is negative. For the x-axis, right is positive, left is negative. So they're asking you at what values of y and x is y positive. So if you look at the graph, you see that this graph is only positive for the y. For the x-axis, these are the positives for the graph, and these are the negative. For the y-axis, here up is a positive, here down is negative. So you notice that from this point where x is -2, let me write it here, x equal to -2. So here where x is 0.5, because this is the middle of 0 and 1 and 1, 0.5. These are the points where this graph is what? Y is positive. So let me write it here so it will be clear. From -2, right, is less than x. Let me use this notation, and x is less than 0.5. Meaning that once x is more than 0.5, imagine that immediately you move a little bit beyond 0.5, y start becoming negative. On the other hand, if you move beyond -2, y also start becoming negative. So if you use our greater than notation, it means -2 is less than x. That's all. These are the values of x. So -2 is less than x, and x is less than 0.5. Are we together? It means -2 is less than, I don't know if we really understand the notation. If I'm to separate this notation, I'll be like, if x is greater than -2, let me put it this way, x is greater than -2. Like x must be greater than because anything like this -2, here now is -1.5. -1.5 is more than -2. -1 is more than 0 is more than. So when x is greater than -2, and remember what and is. And means two of them must be true for it to be true. And x is less than 1.5, because once x passes 1.5, the graph starts entering the negative side of y, and x is less than 1.5. It's actually the condition for y to be what? Positive. So this condition, to write it in one sentence, it will translate to that here now x is greater than -2, right? Meaning that minus is less than x. While here x is less than 1.5, meaning that x is also, sorry, 1.5, I'm writing 0. Okay, 0.5. Oh my god. Sorry for that error. So here is x is less than 0.5, meaning that x is actually less than 0.5. That's why you see this kind of notation. In case you see it in your answer, you know what it means. Now let's go to exercise where we are going to solve it from scratch by ourselves. So let's follow up properly. So we have exercise 7b, number 7, given that y, this is the graph, is x squared minus 2x minus 1, and copy and complete the table. Now this is the range we are using, right? From -2 to 4. So to make it easy, the next thing is s squared. I want to solve this from scratch so we understand everything. S squared, right? I'll put s squared. The next thing is minus 2x. I'll put minus 2x. The next one is -1. I'll put -1. Mind you, this -1 is a constant, so everything will be -1, -1, -1, -1, -1, -1, and -1. Now, squared, -2 squared is 4, -1 squared is 1. Sorry, it's 1. 0 squared is still 0. 1 squared is still 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. Then minus 2x. Minus 2 times -2 is 4. Minus 2 times -1 is 2. Minus 2 times 0 is 0. Minus 2 times 1 is -2. Minus 2 times 2 is -4. Minus 2 times 3 is -6. So minus 2 times 4 is -8. I think we've already gotten everything like this. First we are going to do is to add here. 4 plus 4, 8, minus 1 is 7. 1 plus 2, 3, minus 1 is 2. 0 plus 0, 0, minus 1 is -1. Then 1 minus 2 is -1. Minus 1 is what? -2. 4 minus 4, 0 minus 1 is -1. 9 minus 6, 3. 3 minus 1 is 2. 16 minus 8, 8 minus 1 is again 7. So it will go down and come up. Now the first question is, state the range of values of x for which y is positive. Now look at it. So if we do not use the graph, we can only use integer. But you know, within the graph, you can get some. Maybe there is a value between these two. I can get for the x. So you can say x is. Look at it. Let's get it. The first one is the positive side because there is a negative in between. The first positive. I'm using just this table. Normally we solve this after solving it here. we're also going to solve it with, okay, let's wait. Let's leave it. When we solve for the graph, get it from the graph. But just know that x, the values of x when it's positive here and the values of x when it's positive are what we're going to fraction out. You understand? So let's go to the next. The next thing is find the graph. So we're going to now draw a graph of this x as against this y. So let's do that. So excuse me. Now I've written out the x and y values here. Now I'm to plot the graph. Excuse me. So the next thing we're going to do is, now y has from 7 to 7. So meaning the lower and the upper limit are 7. Y for x start from -2 to 4. Let's start with x first. Let's say this is -2 here. The next one is -1. The next one is 0. Next one is 1, 2, 3, and 4. So we are using one, like normally you used to have, if you are doing your mathematics, it usually used to be done in cm, but I don't want to use that so I don't confuse my student, depending on the let me say the length of the word they want to use. So what we are using here is one of these boxes represents 1 unit of my x, meaning this line is 10 here. So each of the line will be 0.1 unit of my x. So for my x, let me write it out. X is 0.1 for the intervals. Then for y, since it's 7, 7, 1, 2, 3, 4, 5 is not up to 7. So I will go by 2. So this is 0. So here will be, I will start with -2, -4, -6, -8. So that 7 is already inside here. So here will be 1, 2, sorry, here will be 2. I think I'm making a mistake. Forgive me for that. Because it's the same interval. Here will be 4, here will be 6, and here will be 8. So that done, I'm now going to strike my line. So I've drawn the line. Here, I don't know if this is visible. Here is -2. Let me write it out here again. -2, -4, -6, -8. And here is 2, 4, 6, 8. So let's start. When our x, I'll use this other color. When our x is -2, y is 7. This is -2, y is 7. Remember, the middle of 8 and 6 is 7. So 1, 2, 3, 4, 5. So I'll cross it to where -2. This is where -2 is. So I'll use x. The next one, when x is -1, y is 2. This is -1, y is 2. So is it easy? Where 2 and minus. I'm just doing for where 2 in x and minus. Are you serious? When x is -1, y is 2, not plus, is up here. Because this is positive. I'm using negative here. So this is not there. Cancel this out. So the next one, when x is 0, y is -1. This is x being 0. I think I'm messing things up. Sorry. Let me start again. I'm not going to cut it out from video. I want us to see the errors that we're making. When x is -2, y is 7. So this is x being -2, y is 7. So it's supposed to be up here, not down. So 1, 2, 3, 4, 5. So take it. So this is -2 side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is 7. Forgive me for that. When x is -1, y is 2. This is correct. When x is 0, y is -1. This is x being 0. So y will be -1. -1 is somewhere here, middle of 0 and 1. So it will be 1, 2, 3, 4, 5. So these are the correct points now. See the direction. Next one, when x is 1, y is +2 again. This is x being 1. Then y is 2 again. It's going up again. So when x is 2, y, are you sure I'm getting something correct here? When x is 1, y is +2. Are you sure? Let me check. Sorry, when x is 1, y is minus 2. I made a mistake here. So let's continue. So when x is 1, so let me cancel this. I just suppose this error is not confusing my student. This is the correct one. This is the correct one. This is the correct one. So when x is 1, y is minus 2. This is minus 2 for y, and this is 1 for x. So this is 1. Let me write it out properly. So we have 1, 2, 3, 4. So when x is 2, y is minus 1. This is x being 2. And y will be minus 1. Minus 1 is this center here. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 now. When x is 3, y is 2. This is x being 3. And this is y being 2. This is where they will meet. And when x is 4, y is 7. This is why x being 7. If you go up, the middle of 6 and 8 is the 7. So if you go up here, 1, 2, 3, 4, 5. 5 is the middle of, because this whole line is 10, so 5 is the middle. So these are the lines that we need. 1, 2, 3, 4, 5, 6, 7. Let me circle them, because I made a lot of mistakes in this graph. So let me circle them so we can distinguish them from the errors. When x is 0, y is minus 1, 2, x is. So these are our points. Neglect any other thing outside this. So the next thing we are going to do is look for something to, you can do freehand sketch if you want, but the best way is to look for something that can cover and pass through the center of all these points. Are we together? So I decided to use a broom. Make sure that it crosses through the center of all the circle. Sometimes, most times I might not be the one doing it. I might need an extra hand, but let me try. As you can see, it must pass through the center of all this circle that you have here. So I can now sketch it out. Don't just sketch it individually. Take the whole line at once. That's how to get the best line, they call it line of best fit. You just follow it. Because if you take it without taking them together, so this is what I got. Because I'm doing it alone, I think I have some hard time, but let me just join it in a way that we can see it. So, sorry for the roughness of the work. So let's just, okay. As I said earlier, sometimes French curve is okay, but the problem with French curve, like what I'm doing now, is too big. It doesn't usually cover things like that. Maybe to take it part by part, depending on the minimum point you should take is 3. So 3 and above. Let's say we're using French curve, you can take 3 and get it. Try to, from where you stop, take another 3. It works that way too. So now let's start answering the questions. I believe we just got this. It's a rough work, but we'll see how close we can get to the answer with it. So let's answer the next question that was asked. So this is the question. We say we should draw the graph which we've drawn. The second one is the value of, as you can see, we are giving scale. I didn't bother to use it. So, but if you look at it very well, they say 2 cm for 1 unit on both axes. I didn't even bother, just try to go by my own scale. So let's go to the next one. The value of y. But if you're writing an exam, try to use the scale that you are given. My own purpose in this class is to make you understand this graph, not to start going into some things. The value of y when x is 1.3. So x 1 point. Okay, let me use the black pen. I think that one will be more clearer. X is 1.3 and y is what? Question mark. Then the second one, the value of x when y is 6. Y is 6 and x is what? Question mark. Then the next, the minimum value of y. E is y minimum. This y minimum is, I think there was a question I wanted to answer in the last where I said what value of x. I think if we are to go back, we say the range of value of x for which y is positive. As you can see, let me start with that one. Y is positive when, if you look at it, x is less than, starting from here, 1, 2, 3, minus 0 point. Because anything here is less than whatever that is there. So you can see, let me see, you can see x is less than minus 0.3. And also x is greater than, this is 2, right? 1, 2, 3, 4, 5, 6. X is greater than 2.6. These are the two values that give y values to be positive. That's the first question. But mind you, in this case, you know the other one, when we finish doing it, we're able to do something like one value. Let me say a is less than x and x is less than b. But in this case, we can't have such thing. We're able to do it because here is less than this, so x is in between. But here x is not an in between value. I don't know if you get it. It's like a value outside, but that's by the way. So these are the values of x that makes y positive. Then the second one is, what's the value of y when x is 1.3? This is 1.3. This is 1. So you now count 1, 2, 3. So this is 1.3. You now start tracing it down. At the point where it hits y, so you see where it hits y, and so at the point where it hits the graph, you now trace it that point. Trace it like this, where it hits. So from here now, see where it hits. You now trace it. I think it's in the middle here. Yeah, but this is where it hits. I hope you are seeing it. I don't know if this, we need to zoom out to it to see. From here is in the middle here. So for us to know what actually this point is, we now start. Remember that for our y we're using 0.2 for each unit. Each line represents 0.2 of y. So from here, if we count 1, okay, this is the line we are counting. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. And that now is in the middle of this 9 and 2. Now these are supposed to be counted because here is already busy, too busy, so that's I'm counting it outside here. This 9. So in the middle of 9 and 2. So 9 times 0.2 is already 1.8 plus the half here. That is 1.9. So I'm getting it that my y is 1.9 as my answer. Now the same thing we did in the other class. For you to confirm if this is the real answer, remember this is the graph we are plotting for y is equal to x squared minus 2x minus 1. Just put the value of your x as 1.3 and see what you get, and see how close it is to this 1.9 that we got. So this is 1.9. Let me write it out where you can see it. X is 1.3, then y is 1.9. This is our first answer for answer number B, question number B. So let's go to question number C. Sorry, this is question number C, right? For question number D, when y is 6, what is x? When y is 6, so let's go look for where is y 6, and the 6 you're talking about is positive 6, so we'll come here, this is 1. So this is x here and here. So let's trace it down. Let's trace it down. We'll trace here 1, 2. We'll just follow this line down. My work is very, very rough. I'm sorry for that, but I think we'll still get something close. So if you count here, 1, 2, 3, 4, 5, 6, 7. This is it. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. So here is 1.8 minus 1.8. So the first value of x. Then the second one, we'll trace it down here. Is at the middle here. It's at the middle here. So it's at this middle, like here. It'll be in between 8 and 9. So here, let me say here is 3.85, something like that. So I can now say for this question C, right? I'm just writing it here so we can see it. This question D. When y is 6, x is minus 1.8 that we got here and 3.85 that we got here. So if you want to know if these two things are correct, just replace here by 6 and solve for this equation. You know, this is a quadratic equation, so you're going to get two values and check whether those two values are equal to this 1.8 and 3.85. So the last question says, what's the minimum value of y? The minimum value of y is the climax of this, where this curve took a turn, the least value of this curve. So if you check it very well, this curve, the least value of this curve actually is 2. Remember, we have a coordinate here which is 2, but it's negative 2. So at that point, y is negative 2. So these are the three things. First is the maximum value, the value at which value of x at which y is positive. We got this. The second is if x is 1.3 from our graph, when x is 1.3, this is 1.3 somewhere here. Y is 1.9. Second one, when y is 6, this y being 6, we take the value of here and value of here, and we are getting 1.8 and 3.85. But if you check this, if you solve it maybe with your calculator, solve this with your calculator, making y 6, the real answer is actually 1.8 and 3.8. This 5 is not able because of the roughness of our graph. I believe that's where this extra 5, but we are very close to it. At least our accuracy is very, very high. So finally, the minimum value of y, with that one, don't even need to solve for it. And it's easy for us because when we are plotting this graph, the minimum value where y start taking the turn is -2. You know, it's not a must that your answer will fall into coordinates. Sometimes it might be, maybe say somewhere here and it's still curve here. So it's just for you to take that place the curve is and trace it to your y-axis. So the minimum value of y is -2. So that's that for the class. Any question you can drop in comment section and follow up. Thank you. I'll see you next class.